needed money for her kids. And I was like, oh, and she's like, I'm about to cry. She's really excited.
Don't abuse it. All right, here we go. So, what do you look at to determine if the net force is equal to 0? Don't answer this out loud, just think. Do you look at the motion of the object or do you look at the free body diagram? Just think, don't answer verbally. Answer in your brain. Tell your neighbor.
I don't know.
I kind of just like figure it's like
you know what I mean?
Yeah, there's a little bit of emotion of the object. Yeah. But I also feel like the free body diagram helps me figure it out too. That just shows you what forces are active. I can't tell like which one I need and which one helps.
Correct answer is you look at the motion, how the object is moving. So the follow-up question to that is how would you describe the motion when the sum of the forces are equal to 0? Think. Tell your neighbor. Okay, follow-up question to that. Can an object be moving and the sum of the forces be equal to 0? Yes. When would that be the case? It's moving at a constant velocity. Okay, so if it's doing what inertia wants to do, if it's moving at a constant velocity, if it's at rest and staying at rest, the sum of the forces, are equal to 0. Okay, so do not tell me, hey, it's not equal to 0 because it's moving. Right? Tell your neighbor when it's not equal to 0. Okay, hopefully you said when it's slowing down or speeding up, when it's doing what inertia doesn't want to do, when there's acceleration, any of those work. Okay? So, when you're doing the setup, when you deal with forces, if the problem mentions something with force in it, probably a good idea to do this. Okay? Big picture, you've got two different setup things. You've got a free body diagram in this setup, and then you've got the motion, the variables, and which kinematic equation you're going to pick. Both of those interact with each other through acceleration. Does that make sense? Like acceleration has to do with force is equal to mass times acceleration. And then kinematic equations, one of the variables is acceleration. Okay. So I copied and pasted this from last unit. Okay. Draw the free body diagram. Pick the way you want it to be the positive direction. Usually the direction it's initially moving. Make that the positive direction. In free fall, up is always positive in free fall. Okay. Look at the motion to determine if the net force is equal to 0. Is it moving? So real quick, at the highest point here, what's the velocity? 0. Is this staying at rest? Is there acceleration? Yes. Okay. So it needs to be at rest and staying at rest. Okay. Or if the velocity is changing, not equal to 0. Then add up all the forces, keeping in mind the direction, which one's positive or negative. And then if it's equal to 0, set that up equal to 0. If it's not equal to 0, set that up equal to mass times acceleration. This is what I'm talking about when I say set it up. Draw the free body diagram and then set up the net force. All 5 steps. That's what I'm talking about. Okay. On the test tomorrow, there's lots of opportunity for math problems. But I don't want to take the whole time for you to like crunch out math problems, but trying to bake up a way to have you set up the problems, not necessarily solve all of them. Does that make sense? I just want the setup part. There will be a part where you have to do the whole thing, but some parts you're just going to have to set it up. Okay. All right. Determining direction of acceleration is taxing. There are 3 different ways you can figure out the direction of acceleration. One way is in terms of the net force. So think about how you'd figure out direction of acceleration based upon the net force, the total force. Tell your neighbor.
Yeah.
Okay. Mathematically speaking, see if you can follow, if this makes sense. Does force have direction? Is it a vector? It got pushed that way or pulled that way. Does have direction. Does mass have direction? Does acceleration have direction? So mathematically, whatever the direction of the net force is, that has to be the same direction as the acceleration, because like the direction times something with no direction has to be that same direction mathematically. You okay with that logic? Okay. This is always the case. The net force, the direction of the total force is always the direction of acceleration. This is what causes this to happen. Okay. Now, one point of some way you could misinterpret me on that one is what I'm talking about is it's the total force, not just one force. It's the total force. So you need to figure out what's the direction of the total force before you can figure that out. Okay, good with that? Tell your neighbor how you figure out the direction of motion based upon, the direction of acceleration based upon the motion.
So if it's this is the trick.
Okay. Hopefully your conversation sounded like this. If you're speeding up, then the sign of acceleration is the same as velocity. If you are slowing down, then the sign of acceleration is the opposite of velocity. Okay? Sign of acceleration cannot be determined by the way you're moving. It's incorporated. That's part of it, but it's not the sole determiner. Okay. Also, do not associate speeding up with a positive acceleration and slowing down with a negative acceleration. Okay. So if you are speeding up, velocity and acceleration are the same. If you're slowing down, velocity and acceleration are opposite. Okay. Tell your neighbor how you figure out the direction of acceleration from a velocity versus time graph. Okay, everybody go with that? Slope. Okay. Now, these problems I have posted on Canvas, but I've also made a PowerPoint out of them. If you're like, I got this, I don't need this, totally fine. But if you're like, test tomorrow, I would highly recommend engaging in this process. Okay, the cups. Here's what. So while you're working on a problem, have your cup tipped over. If you're done with the problem, have your cup upright. If you have a question, tip your cup upside down. Okay. If you're not participating, totally fine. I'm not taking that personally. Give your cups like don't. Yeah, it's on Canvas. It's the last file. Yes, or either way. So while it's laying down, that means you're working and you're good. You're just in progress. If you're done, then have your cup upright. If you don't know what you do, you're stuck. You have a question, tip your cup upside down, and I will come to you. If you don't remember the equations, you're like most everybody else. Pull up the file. What this is on Canvas has all the equations. So you can pull that up, or you can pull out your lab that has all the equations. Anybody not get a cup that wants a cup? Working question, yep. And upright, I'm done. Use a little ridge as a little hand holder right there. And I'll give you a head start, and once there's several cups upright, then I'll start going over it. a great question. So, no, you're good. You're good. What's happening here?
Oh, okay.
You good?
Yeah, thank you.
You go.
I was trying to be quiet.
Yeah.
You were like,
I was already done.
the piece comes all over.
Okay. Any other questions? All right. Here we go. All right. So I'm dealing with forces. So I'm going to draw a free body diagram. I'm going to say it's going to the right. So applied force is going that way, friction is going this way. I'm going to make the way it's moving positive. Okay. I'm not going to put numbers on here, just symbols. And then some of the forces. Tell your neighbor, are they equal to 0 or not? Tell them why. Tell them why you know. Okay. Constant velocity. Some of the forces are equal to 0. So you have applied force minus friction is equal to 0. That's your setup. Applied force minus 3,000 is equal to 0. So applied force is equal to 3,000 newtons. Okay. A popular pitfall is to say it's equal to mass times acceleration. And go 200 times 9 because I've got numbers. So I got to stick them somewhere. Okay. What is the unit for acceleration? Meters per second squared. If you did that, that is an automatic minus 3 points. And you probably missed 3 points on the last test because that's exactly what I gave you with the dog sled problem. Does that make sense? Okay. The value of acceleration is going to be what? Well, wait. Okay. Is everybody good with y? Okay. All right. Same scenario. Kind of a secondary question. So tip your cups. And come up with smaller cups.
So like on the test for the so we had one like that. Do we have to draw the free body diagram every time or something like this?
Good question. For Multiple choice, no. For free response, yes. Okay. The easiest way, in my opinion, to do this problem is just to employ that question or that equation, because the average velocity is the actual velocity if your velocity is constant. If you're always moving at 9 meters a second, then the average velocity of that is 9 meters a second. Okay? That's the easiest way to do it. And you find that to be 90 meters. Okay? Okay. Now, there are other ways you could do it. You could say initial velocity is 9 meters a second, and final velocity is 9 meters a second. Both are going in the positive direction. You have a time of 10 seconds, and you're looking for delta x, and use this equation. Just make sure that that's 9, and this is a plus in the equation, not minus. You're adding 9 plus 9. Okay? Now, here's another pitfall. Acceleration is equal to velocity over time. Acceleration is equal to the change in velocity over time. Final velocity minus initial velocity. Tell your neighbor what the value of acceleration is in this problem. And tell them why. You have 9 minus 9. There is no change. Velocity is constant. Therefore, acceleration is 0. So you could employ any kinematic equation that has delta x in it and get 90 meters. You have lots of options. How are we doing? Doing all right? Yep. So I'm changing the scenario a little bit. We're still on our swamp boat. Okay. The free body diagram didn't really change. I mean, if you wanted to draw it to scale, then I guess this is shorter, but you're not really putting numbers on your free body diagram. Some of the forces are not equal to 0 because you're slowing down. And the process is slowing down. Okay. I'm still making to the positive, sorry, the way it's moving positive. So I've got applied force minus friction is equal to mass times acceleration. Okay. That's my setup for the free body diagram, the forces. Now, I'm looking for how far. So that tells me I'm looking for the motion part. So I'm probably going to incorporate a kinematic equation. And I'm looking for how far this is going to take. So I have my initial velocity is positive 9 meters per second. My final velocity is a positive 3 meters a second. I'm looking for displacement, and that's what I have, which is not enough to figure this out. I need one more variable. I need one more piece of information, and that is where our free body diagram and our setup for kinematic equations are linked. Is if I can find acceleration from over here, that's going to be able to give me that additional variable to be able to finish this problem. Does that make sense, the strategy there? Okay, so I have 1,000 minus 3,000 equals 200 times A. Okay, negative 2,000 divided by 200 equals acceleration. Acceleration is equal to negative 10 meters per second squared. Once I get that, it's a negative 10 meters per second squared. And now I've got enough information to do either. You could either choose, oh no, you can't. You're just choosing this equation. This is the equation that's going to get your answer straight away. So you have 3 squared, 9 squared plus 2 times negative 10 times delta x. So you get 9, 81 minus 20 delta x, and negative 72 divided by negative 20. You get a 3.6 meters. Okay, then you look to see, is this a ridiculous answer? Pretty short, but it's not like unrealistic. Like it's not like, what? 10 feet, not stopping, but just slowing down to that. Sure. How do we do? See how these tie together? Okay. Okay. Here's next problem. Okay. So my free free body diagram is going to be, nope, that's good. It's moving to the right, but the force is acting to the left. I'm going to make the way it's moving initially positive direction. I don't have to. I could make to the left positive, but everything I make negative should be positive, and everything I make positive should be negative. If I made it the other way around. Some of the forces are not equal to zero because your velocity is changing. It was going to the right, and now it's going to the left. So your velocity is changing, so some of the forces are not equal to zero. So you have a negative applied force is equal to mass times acceleration. Okay. So initially you're moving at 50 meters a second. And now you're going negative 50 meters a second. So your initial velocity is a positive 50 meters a second. Your final velocity is a negative 50 meters a second. You're looking for how much time. Based off of that, you don't have enough information to do a kinematic equation. So that's where you look to your free body diagram. It's like, hey, if I could find acceleration, that would be nice. So I got negative 100 Newton is equal to 40 kilograms times acceleration, and find my acceleration to be negative 2.5 meters per second squared. Okay. That's a negative 2.5 meters per second squared. So with that information, I can either choose this equation or this equation. Here's a little fun fact for you. These two equations are identical. They're just rearranged. So negative 50 is equal to positive 50 plus negative 10 times delta t. So we got negative 100 equal, no, not 10. Where am I getting 10 from? Negative 2.5, sorry. And that equals 40 seconds. Good with that? Okay, you see why I wanted to find which way is positive from the beginning. And that's an important detail in your setup. Okay, good with that? And follow up would be, what is the displacement during that process? Okay, for the sake of time, you could do any kinematic equation you want to, so long as it has delta x in it. And you found your answer to be 0. Okay? Check this out. Here's a connection. Ready? If I throw this up at 50 meters a second, how fast is it going here? 50 meters a second in the opposite direction. That's true if the acceleration is constant. What was my displacement? 0. Ended up back to where it started. Yeah. Cool with that. You could pass your cups forward. Test tomorrow. I'll be here after school.